Okay, today we are going to start what's called optimization. Optimization. A lot of times you all ask, either out loud or you think in your head, when am I ever going to use this? Optimization is one of those things that's actually like very highly used in real life. The idea with optimization is you want to find the maximum or minimum of something. The maximum or minimum of something. So where this is leading us to is what's called linear programming. Linear programming, we're going to find the maximum or minimum of something subject to what's called constraints. So we have some things that are limiting us, and within those limitations, we want to find a maximum or a minimum. So you might be asking yourself, when is this actually practical or used? If you think about owning a business, let's say, maybe you want to make the maximum profit at your business, but you can only spend a certain amount of money hiring employees. Maybe you can only spend a certain amount of money on supplies. So you want to know, what is the maximum profit that I'm going to make within these constraints that I have? We're going to do the basics of it today, and then for those of you who are here on Monday, we're going to add on to it a little bit. Okay, so here's how you're going to see a problem. This is the one example that you are going to do. You have what's called the objective function. The objective function is the one that you want to find the maximum or the minimum of. Example 1 tells us we want the maximum. So we want the maximum of this function. These are our constraints, though. These are the things that are limiting us. So the first thing that we are going to do is we are going to graph those constraints. One thing that you're going to see, you will always have this same constraint. That constraint is just telling us x and y have to be positive. So we're working within the first quadrant. We're going to start by graphing that. I'm going to make this my x-axis, and I'm going to make this my y-axis. So I'm only working in this first quadrant where x and y are positive. So that's that. Oh, not that one, sorry. That's this one. Okay, next thing we're going to do is we're going to graph this one. That's in standard form. So we're going to find our intercepts, like you did on the test. If you plug in a 0 for x, you get y to be 12. If you plug a 0 in for y, you get x to be 12. Sometimes those intercepts are going to fit on the graph, sometimes they won't. So just know, sometimes you might have to count by 2s or 3s or 4s or something. There are 20 boxes, so we'll be able to get to 12. So we're going to graph those intercepts. So go to 0, 12, 12, 0, and put some points there. And this is going to be a solid line. Make sure you draw a straight line and that it's very accurate. And you'll see why in a minute. It is an inequality, so there's going to be some shading. If we plug in 0, we get 0 plus 0 is less than or equal to 12, which is true, which means we're shading on the side that has 0, 0. So that is that second inequality. Okay, so then lastly, we're going to do this first one. This is in standard form. You're going to notice this one's going to be a little bit trickier to graph. If we plug in a 0 for x, we get y to be 0. If we plug in a 0 for y, we also get x to be 0. So the unfortunate part of this, that only gives us a single point. That gives us just a single point. You do not get to graph this line wherever you want. what's one way I could go about graphing the rest of this line?
Just plug in another point.
Plug in another value. What do you want to plug in, Charlotte?
4 for x.
4 for x, okay. So if we plug in x equals 4, we have 4 subtract 2y is equal to 0. So 2y equals 4 and y equals 2. That's the point then, 4 comma 2. So we're going to graph that.
Can it be negative 2? Or wait, no.
So that goes like that. Again, we have to figure out shading. We can't plug in 0, 0 because it's on the line, so we got to plug in something else. Owen, what would you like to plug in?
1, 1.
1, 1, so right there. Okay, so if we plug in 1, 1, we get 1 subtract 2 times 1 is greater than or equal to 0. So 1 subtract 2 is greater than or equal to 0, which is not true. So we do not want to shade where 1, 1 is. We shade on the other side of the line, which is this way. Okay, so then this is our region where everything intersects. This term or this region has a fancy name. It's called the feasible region. Feasible region. And what we know, or what I'm going to tell you, is the maximum and the minimum is always one of the vertices of the feasible region. Always. It's not going to be anywhere else. It's going to be one of the vertices. So the last thing that you're going to do is you're going to find the maximum. And here's how you're going to do that. You're going to make yourself a table. On one side of the table, you are going to list all the vertices of the feasible region. There are only 3 of them. So one of them is 0, 0. One of them is 12, 0. And then this point right here looks like it's 1, 2, 3, 4, 5, 6, 7, 8. 8, 4. Is what that one looks like. And you are going to plug all of those into the objective function. So if we plug 0, 0 in, we're going to get 0 plus 0, which is, of course, just 0. If we plug in 12, 0, we get 50 times 12 plus 0, so that's 600. And then we get 50 times 8, and this ends up being 700. Very last step is answering the question. We were asked for the maximum, biggest number, so the maximum is that number. Here's how you're going to write that. The maximum is 700 at the point x comma 4. The maximum is 700 at the point x 8 comma 4. Sometimes you'll be asked for the minimum, sometimes you'll be asked for the maximum. Sometimes there's going to be 3 vertices, sometimes there will be more than 3. Okay, question for you. This point I can very clearly see is 8, 4. Does anyone know how you would find that point if it wasn't clear like it is here?
Plug it in into your graphing calculator.
And do what?
Find the intercept.
Okay, you could do it that way. Other way that you could do it, and you might have to do this in your homework, you might have to solve the system with those 2 lines. So these 2 right here, the green and the red. Solve that system using substitution or elimination to find the last point.